Hi all, see this, in this particular problem we are asked to check the differentiability of the function in general at the point x equal to 0 and x equal to 1. So, we will all consider the neighborhood of x equal to 0 and x equal to 1, that's the important constant, right. Now here we'll solve this problem by testing, okay, all other options, right, without going ahead and prove it in general way, okay. So let's go ahead and concentrate about the option 1, okay. Now in option 1 it says that a equal to 0 and b equal to 1, okay. So therefore my given function fx, let us take that as option A. We are actually testing that option. So therefore my function fx will be reduces to a is 0 and b is 1. So therefore in this case we'll say that this portion is goes off, so we'll have that only other part. So therefore we can say that this actually gives you b mod of x and sine of mod of x cube plus x. So that's our function, okay. So now we need to test that at the nearest point of x equal to 0, okay. So that's it, okay. So here we will consider that x tends to 0 case, that is in the neighborhood of x equal to 0, that is in the interval x minus some h, 0 minus h and 0 plus h, right. In this interval only we are trying to observe that function, not anything else, okay, because then the problem became little complicated and all that. So that's why we are concentrated on this interval only, okay. So here also there is two cases, right. One is x greater than 0, x less than 0, right. So therefore if I trying to consider that x greater than 0 case, obviously here we have to understand that our x lies in this given interval. Now x greater than 0 means that obviously we can say that the given function fx is reduces to b is 1 is given. So therefore we can say that it's actually mod of x. So that mod of x will be reduced to, right, as x, because by the definition of mod x. And also when x is greater than 0, right, we can say that x cube plus x is also greater than 0, and that's why we'll say that gives you as sine x cube plus x. So that's it. If I consider the condition that x less than 0, so in that case my fx will gives you as minus x, and x cube plus x is less than 0, because for a negative values of x both are negative. So therefore that function will be reduces to sine minus x cube minus x. Now sine of any function with minus is positive, so therefore we'll write down as sine x cube plus x. And that's it. So therefore we can easily observe that, right, the given function, okay, are actually became the same form in the neighborhood of x equal to 0, right. So if I calculate the right limit or the left limit, we have to choose this function, okay. So at this function it is obviously a sine function, so it is differentiable. So we'll say that function fx is differentiable at x equal to 0 for a is equal to 0 and b is equal to 1, okay. So that's it. So therefore we can easily say that for this particular case, right, that option A is correct. Here I can remove that because b is 1, okay. So that's it. So therefore we can say that option A is the correct option, but that is not done, right, because some problem in JEE obviously will have that multiple option may be correct. So that's why we have to check the other options as well. So let's go ahead and check that option B. So here it says that x equal to 1, a equal to 1. So therefore in this case obviously my function fx gives you cos of mod of x cube minus x, right. Now here we have to test that for x equal to 1 case, right. Now at x equal to 1 means that here we are trying to say the condition, the case x tends to 1, that is we are looking in the interval one minus h to 1 plus h. Obviously, h is tends to 0 or h is very small, okay? That's it. Now, if I go ahead, we have to check this function, right? What is x cube minus x at this case, right? So, first we consider this x cube minus x and let us observe that, right? Now, see that. That if I consider that x cube minus x and equal to 0, that's imply that it's x multiplied by x squared minus 1 equal to 0. That's imply that zeros of this function is x plus 1, x minus 1. And that's why the zeros are actually x is equal to 0, plus 1 and minus 1. So why we need that? Because I need to sketch that x cube minus x, because always sketching gives me the easiest way to interpret the answer of the problem. So here marks that. So this is minus 1, 0 and 1. We'll see that at any point at x equal to minus 2, the function value is negative. Taste that it is minus 8 and plus 2. So it's negative. So therefore we can see that our plot of this function will be something like this. Okay. So therefore we can understand that 1 plus h, right? X cube minus x is actually positive, 1 minus something, it is negative, right? But in any cases, let's write down that. So therefore it's imply that x greater than equal to 1, x cube minus x is actually greater than 0, and x is less than 1, x cube minus x is less than 0. Okay. Now, only one case you have to test that. Wherever I wrote that x greater than equal to and all that, we have to see that this is the interval we are talking about. That means x less than 1 means is actually that it's less than 1 but not exceeding that limit. So it's actually talking about closing to that plus 1. Otherwise, obviously the function will change as obvious from this function. So in both cases, we can see that function fx is equal to cos of x cube minus x when x is greater than equal to 1, and obviously that cos of it is the of minus x cube minus x when x is less than 1. Now see that in that case, right, cos function cos minus x is also positive. Therefore we can easily step jump one step and say that this actually gives you the same function. Okay, so that's why again we'll say that the function fx is differentiable at x is equal to 1 for a is equal to 1, b is equal to 0. So the second option is also correct. Now we will have two other options left. So C and D, that option need to be checked based on the similar approach. So let's go ahead. Now here it says that for C, it says a1, b0. So therefore my function fx will be reduces to a. So a will be not there because a is equal to 1. So I just remove that, and then it gives you as cos mod of x cube minus x. So that's my function. Now we are looking for x equal to 0, right? So now we can see from this function itself, we can understand that if we are talking about that interval, so x tends to 0 case, that is inside the interval 0 minus h and 0 plus h. Now in this particular interval, see from this plot, right, 0 plus h, the function is negative, and 0 minus h, the function is positive. So therefore we can say that based on the similar approach, we can say the function fx is equal to cos of x cube minus x when x is greater than equal to 0. And also we can say the same function repetition of the function x cube minus x when x is less than 0. We can conclude the same kind of phenomena, say stating that cos is a even function. So as it's an even function, so therefore less than 0, greater than 0, the values will be very similar, right? So therefore we can easily say that that function is differentiable. So therefore here also we can say that that's imply fx is differentiable at x equal to 0. But here they give it as not differentiable. So therefore obviously that option C is false. Test for the next one. But next one is the combination of both. So we can consider that fx is equal to a cos of x cube minus x plus b of, so I just write mod x sine x cube plus x. Okay. Here this one need to be removed and the mod need to be present. So this should be mod, not that open bracket. Okay. Now see that. Now what case we are looking for? In that particular case, we are looking for to find this testing and all that stuff with respect to the point x equal to 1. Now look carefully. At x equal to 1, that x cube minus x is already written, right? So whatever happened, one plus case or one minus case, cos x cube minus x always gives you the same value, right? Near about that. Now we have to test it for x cube plus x. Now let's see that x cube plus x. Now if I go ahead and trying to plot x cube plus x, right? So see that x cube plus x means x taken common, x square plus 1. That means here we can have this plot like something like this, right? Because only the function has a roots at x equal to 0. The remaining roots are complex, right? So this can obviously the possible plot of x cube plus x, right? Now see that here we'll talk about x equal to 1. So therefore if I talk about x equal to 1, right, it is always positive. So therefore that x cube plus x is become always positive and mod x is always positive. So therefore we'll say that in the neighborhood of, so neighborhood I just wrote by NBD here, neighborhood of x equal to 1, that cos mod of x cube minus x will be equal to cos of x cube minus x, and that mod x of sine of mod of x cube plus x will be equal to, the mod cannot be there because both are positive. So therefore you can say that it's x cube plus x. So therefore fx is became cos x cube minus x plus x into sine of x cube plus x in this neighborhood of x equal to 1. Now it is obvious that if I go ahead and take that neighborhood function, right, it is obviously differentiable. So we'll say that here also fx is differentiable. So that's it. So therefore that option is also wrong. So therefore for this particular problem, obviously option A and option B are the two correct options, and that's it. Hope you understood the problem. Thank you.